Today we're going to look at a few applications of sine functions. So the first thing I want to look at is a regression. Okay, so they've given us the months of the year and the temperature. This one is saying in Cape Town. Okay, so they graphed these. Notice they made January equal to 1 and so forth. So they've got these points. What we're going to do is we're going to do it both by hand and then with the calculator. Okay, so if you think about it, our sine graph looks something, well, our sine graph, okay, let's just say that's the axis. It starts here and then it goes up and then it goes down and then it comes back to 0. So if I look at this one, I'm not starting, well, let me say it this way. My A value seems to be that kind of initial starting point. So that would be one thing that we're going to need that in just a minute. We're going to highlight that point. We want to know, as in all of these things, how long does it take it to do everything it's going to do? So this curve, notice that Cape Town is warmest in January. This must be a southern hemisphere. Then it gets warm again in January again. So this period is always equal to 2 pi over b. So we need to know our b value that we can write in our equation. So it took it, that's 12 months that it took it to do that. So our period is 12 is equal to 2 pi over b. Okay, so our b value is going to be pi over 6. And so then the next thing we want to consider, we're going to come up, and when we do it by hand, it's not going to be as precise as when the calculator does it. But I want to see, so roughly, this value here had a y value of 28. So I go as high as 28. I'm just kind of scanning through these numbers, and as low as the smallest one here was in July. That was 15. So we've got a total difference from the top to the bottom of 13. So we can say our amplitude is about half of that, 13 over 2, which is 6.5. Is that precise? Is that exact? No, not quite, but it's gonna help us out here. So then, if you consider, we've got A affects the amplitude, B affects the period, C shows any shift left and right, and D shows any shift up and down. What I want to do is I want to consider this point. What normally would have been here, the starting point, got shifted to this point and then up, right? Because normally we start, then we go up first, then we go down, then we come back to 0. Here, if I make this my starting point, I'm going up, and then I'm going down lower, and then I come back. I could, notice, this would I could back it up to a point somewhere around here. So since our sine curves are periodic, we can shift it. We have infinitely many ways that we can shift it. So there's multiple correct answers, but I'm going to use this as that starting value. And so this, September is the 9th month, so this moved 10 places to the right, and then it went up. What is that note? September, so it's our October date, went up about 12 and a half. So once again, these values aren't perfect, so our equation may not be perfect, but we're going to say that roughly our A value, we said, was our amplitude is about 6.5 times, this is a sine curve if we start here, and then our B value, we said, was pi over 6. X, and if I want to shift it to the right, 10, I have to put minus 10. And then you'll notice that this went up. How high did that go up? About 12, I lied, about 21 and a half, 21.5. So this is roughly, basing off of some of the values that we found here, this is roughly our equation by hand. So now we're going to grab our calculator, and I'm going to come into menu. I'm going to go over into statistics. And our months, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, my bad. I was going too fast. 11 is this one. Let me come back and get that to be 10. I was having so much fun. 12. So that's going to represent our months because we're doing January through December, so 12 months. And so then I need to type in the values. The first one was 28. The second one, 27. 25.5. 22. 18.5. Here's hoping I'm not making mistakes. If I make mistakes, do it correctly at home. September is my 9th month. It's 18, 21.5, 24, and 26. Okay, so I've got these points in, and now what I want to do is I want to graph these points. Before I go graph, it's a good idea to kind of set the graph. We do want it to be a scatter plot. We do want our x value to be list 1. We do want our y value to be list 2. I have different options. Let's make that graph 1. Okay, so things looked good. So I'm going to hit graph 1, and there are those points. And that resembles this first little bit of the graph on my paper. I'm going to calculate. I can do the different regression. So if it's linear, if it's quadratic, if it's cubic, quartic, logarithmic, exponential power. Here's the one that I want. I want it to be a sine curve. So when I hit the sine graph, it gives me all of this information. Now you'll notice one thing that's different. When I wrote my equation by hand, I had factored out b. They did not factor out b. Okay, so if I think about this, I'm gonna cheat and use another calculator. If I take, this is pi over 6 times negative 10. This is roughly, well, one of the values that they might have, like if I wrote it this way and the calculator gave me this instead, that means they distributed this through, then we're not so wrong, okay? Let's keep going. So we said we had an a value of 6.5. They gave us an a value of 6.29. That's not too far off. Our period here is pi over 6 is what we said, and they gave us, well, let's see, pi over 6. It's approximately 0.523. What did they say? 0.524. Okay, that's pretty close. The c value looks pretty different than what we expected, but we'll talk about that in just a second. And then we had a d value of 21.5. They had a d value of 21.4. That's pretty close. So what I'm going to do is I'm going to copy this and copy it. It'll go into y1, and I have to hit enter. So now if I draw it, here it is going through those points. Isn't that lovely? So now that's great, but I don't get to do a whole lot with it unless I go back to menu. I go down into my graph. So notice this is plugged in. It took everything that we had here and it typed in with a ton of decimals. Okay, I'm bored already. But it took that equation. Notice it wasn't turned on. I can tell if it's turned on by whether that thing is highlighted or not. I have to, because I was messing with it, it selected it, but if it wasn't selected, I just hit this select button right here. And then I want to type in the one that I got and just see how close my estimation is to the graph that they had. You may notice while I'm typing this in, oh, you know what, I might keep parentheses just in case, I don't remember. Sometimes the calculator gets finicky with all these parentheses. Times, I don't, x minus 10, sorry, I was going to tell you something and then I forgot. I can't multitask apparently. Okay, so I've typed this in. You'll notice my calculator is in radians. So we graph typically in radians. It makes life better. So when I go to draw, here's that one graph, and look how close mine is to it. So looking again, the blue one was the equation that I got when I did the regression, and the red one was the one that I had done as I guessed, or I mean they were educated guesses, but as I kind of worked my way through that. So look how close those are. So now if I wanted to figure out, okay, well, what's the temperature going to be halfway through February? Well, February is the second month. I can do G-solve. I can find the y-calculate. This is the one from their calculator. This is the calculator equation, not the one I did by hand. But now, halfway through February, they're saying that the temperature should be 26.2 degrees. So hopefully that was helpful. Good luck on doing it on your own.